Welcome to this short tutorial produced by Certism LLC. It covers how to use the merge tool in the Impetus AFEA Solver GUI. As an example, start here with a vehicle model. So we have a main command file here. We open that in the sample mode. And you can see here that there are no merge command in this file right now, or in this model. We can see that over here in the object tree. If we go down to merge interfaces, there's nothing there. So how do we apply the merge commands for the parts that we want to have it applied for? Well, we can use the automatic tool here. Go to Tools, Merge, and then it comes up with this dialog box here. That is the tool for automatic merging, automatic finding tolerances, etc. So the thing with the merge command is that it's basically constraining nodes to a master surface, and that means that a part can both be slave or master. And if there's for some reason that you don't want to have a certain part, for example, this part here, not to be a slave in some constraint, then you can flag it off here. So you can do that manually here, and you can also include manually, or you can go down to this one here where we set the include. So let's say, for example, that we want to do merging on part 10 to 15, but also look at what will happen in parts 20 to 30, for example, and say, okay, and what will happen now, as you can see, is that we have deselected these parts, and these are here are still selected. And this is how you then can choose which parts in the model that you want to work on. So now when we have selected the parts that we want to look at, then we also need to find out uh, what is the tolerance for these parts to be merged. And that is done automatically here. And this is why it's nice to have an automatic tool to do that, because these tolerances will change depending on where the nodes are and the shape of the geometry, etc. The way we do it here is that we are using a scale factor, and default is 0.15. But what it really scales is the minimum nodal distance. So that's the mesh dependent. So that means that we are going in looking at each mesh for each of these parts that we're looking at, if they should be tied or not tied, and what nodes should be merged and not merged. So we are taking the minimum nodal distance in the parts involved in a merge command, and we scale it by default 0.15. And then you can, of course, increase that or decrease it if you think it's taking too many nodes or too little nodes, etc. Another thing is that when you're looking at parts that have the same mesh density, sometimes it's beneficial to do what you call a symmetric merge. That means that you're merging nodes from part A to part B and part B nodes to part A. So that means you actually have a double merge. In order to see how close these mesh densities are, we are putting in a percentage, meaning that we are looking at how many nodes from one part will be merged and how many nodes from the other part will be merged. And then we are saying if that's within 5%, equal within 5%, then we'll use a symmetric merge. But you can give that as a use as well. Of course, you'll have more symmetric merging if you increase the percentage there. Now, another thing is that if you want to have self-merging, which we don't use very much, but you can also go in and look at that and see if you will include that if the tolerance within some nodes in that part is within the tolerance distance, then you can allow it or not allow it as well. So now here we are basically ready. We have set everything up. We now can say OK. And here we see that the simulation went fairly quickly. It's going through all that, going through the whole model for the selected parts that we did. It's list here that, for example, for the part here, the slave part is an 11 and the master is 15. It found 17. Then it went from using 15 as the slave and 11 as the master, and it found 4 there. These are not close in numbers of nodes that it found within the tolerance, so that's why this one will not be a symmetric merge, but just one merge. All these you can flag off and on and say, okay, I don't want to have that with me here, or you can have it with you. And they'll be written into this file, as you can see here, all the commands are now automatically written, part 11, part to part 15 within this tolerance. Then you can go in here and you can do like give it a name. And what the point is that this will write out a command file. When I save it here, this command file will then be saved, and I can use that as an include file. That is basically what this interface do. Now I can go out and I can double check if this one is out here. You can go in here and we can see the merge.test file is right here. We can open that in the editor, and you can see here now these are the commands that then I would use in this case to merge with. Now we can go out of this file here, and we can also go down here and close this one down, and we can say, so let's go into the main file. This is this dash main here, and we go into the editor, and we had some include files here, and I can just add star include, and we called it merge dash test dot k. Now you can see it, the red line disappeared, meaning it found that one. Now we should be able, and then we can go in. We could have shown it here quickly as well, going to the sample mode, but let's just go out here and then open it in the sample mode. Now here we have the vehicle, and we should now be able to go down here and actually see that we have merged interfaces. And here they all are. There's different ways we can do it. And they can be shown graphically. If I take the parts off here, there you can see what parts in this case that we merged. Of course, you'll do many more for the full vehicle here as well. You can turn them on again, the parts, etc. And you can do it like this, and we can see where they are in a better view here. So one can see here is the tool, the merge tool in the Impetus GUI is a very strong tool and very useful when you are looking into larger models where you need to set tolerances for each of the merging surfaces, etc., as well as that you can easily identify the parts that perhaps needs symmetric merging. This concludes our tutorial on the merge tool in the Impetus AFEA Solver GUI, and we hope that you have enjoyed watching. If you have any questions, please contact us via support@certisim.com. Have a great day.